But that's not what I need you to do. Yes, that was the common sense, and I am sorry that in high school they are taking your guessing, your critical thinking into like something that is mechanical. But the mechanical way of solving equations, like the algebraic way, is going to help you solve more complex, more difficult equations, where you will have to think about what to do instead of what number fits into X. But don't worry, I'm gonna guide you throughout the way. So this is funny right here. 13 minus X. So I am going to undo what is being done to the X. Oh, subtraction is happening. No, subtraction is not happening. Addition is happening. This is a plus. Addition. The sign to the left of the number is what's happening to the X. Get it? The X is just a negative. But this doesn't mean that 13 is being subtracted from X. No. Let me rewrite this. Let me put the negative X first. And let me put the 13 later. Second. Okay. So now what operation was happening? Yes, addition happened all the way. Okay. So let's get rid of this 13. We know how to do it. We just use the inverse operation. Okay? So I'm going to use the additive inverse of 13. What is the additive inverse of 13? Negative 13. Correct? So now negative X equals, remember, additive inverses cancel each other. So 13 minus 13, that's it. It's 0. So bring down the negative X. Don't forget the sign. You bring it down the negative X. 1 minus 13 is negative 12. So your answer is negative 12. No, son. How? Okay. Secret, and learn it right now. You can never, ever, ever, of all the evers, have a negative variable as your answer. So, how do I fix that? There is 2 ways of fixing this. Okay? So I'm going to show you. You will use the change of signs property of multiplication. In other words, you're going to change the signs here. The X is going to become positive. But then when you change the sign of one side, you have to change the sign on the other side. But how is that possible? How can I just change the sign? Well, think of a number that can serve as a change of signs without altering the result. Well, that number, my friends, is, let me introduce you to the -1 property of multiplication. Multiply by -1. When you multiply by -1, look, 1 times X is still X. Negative times negative is positive. Ooh. Negative times negative is positive, and 12 times 1 is 12. So this is your final answer. That is called the -1 property of multiplication. Okay? Let's continue with this. Okay, so let us go on to two-step equations. Ooh, I'm nice. All right, two-step equations. Oh my God, why is the dog in my... If I move this chair, he's gonna start crying like crazy.
It's been there for years.
Well, you need to move it. All right. So, let's see. Now I have the following. What is this number? Oh my God, I forgot the number. What was the last number? Yo, I'm a mess. I'm not young. Number 8, 9, 10. Okay, number 10. So we're gonna do number 11. Okay, is he moving? Yeah, thank you. Okay. Wow.
Oh, so that's me.
Yes, yes, whatever. Okay. Number 11. So 16. Wow, ugly 6. 16 equals 7 plus x over 7. So you gotta copy this, okay? All right. So how am I gonna tackle this? Now is the time where we're going to start showing proof of how to do this. First, I'm gonna draw a line right here. I don't know how many things I'm gonna use, how much space. So let's analyze what is going on here. Let me expand, let me elaborate on that. So here I have a division of 7 and I have an addition of 7. Addition, not this addition but this addition, okay? So I need to undo all that. So let me do it the way that I was teaching before, not the complicated one, the easy one, okay? Because we have room for that. So what I'm going to do is the following. Remember, you have to undo the operations that have been done. And remember, if you believe in PEMDAS, well, solving a linear equation is the opposite of PEMDAS. For example, in PEMDAS, parentheses, exponents, PEMDAS, multiplication, division, addition, subtraction. No, that's it. Well, so let me see. Actually, you know what? Let me write PEMDAS. PEMDAS. Okay, so in PEMDAS, when you're gonna solve an equation, you're gonna start. Let me see what it spells. You're gonna do SATMAD. Ha! SATMAD! SATMAD! In other words, you are going to work backwards. So, if multiplication or division is the last thing that happened on the equation, well, that is the first thing you're gonna start undoing. It's like this. I'm building ta 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 ta. Now I need to unbuild or destroy or whatever. But we're not just gonna go like that, no. Then we have to start from the last place. Okay? We have to start taking out things from the last thing that we did. That's the first thing we remove. Right? That's it. That's what I'm gonna say. I'm not gonna go into a back line where the first one, no. So I am going to first undo division of 7. And how do I undo division of 7? By multiplying by 7. Okay, cool then. So I'm going to multiply the whole thing by 7. Cool. Alright. Remember, this could be 7 over 1 all the time. So, I need a calculator for this because I could be a math teacher, but I don't see numbers in my head. So let's see now. 7 times 16 is 112. Okay. So I'm going to write here 112. Now equals, because that's what the equal sign was. Remember, you're multiplying everything. We're multiplying sides, not just items. Sides. So the whole side gets multiplied by that, and this whole side gets multiplied by that. So then it's like using the distributive property. So 7 times 7 is 49. I hope you remember this. And then 7 times x over 7 is gonna be, well, I'm gonna actually write the whole thing. 7x over 7. Smells good, like food, steak, oil. Okay. Now what happens here? Remember, you were multiplying by 7 and dividing by 7? That's why they cancel out. So let's bring down what we have left. X, the plus sign, the 49, and then the 112. Okay. what's happening now? Well, x is being added, increased by 49. Okay, not this one. This invisible positive, that's the one. I could write this as x plus 49 if I wanted to. So anyways, so I am going to undo what? Addition of 49, okay, I'm gonna undo it with subtraction of 49. Jesus Christ. Yeah, I know, I write ugly, but you'll understand. Alright, so I'm gonna subtract 49 from both sides. Because what you do to one side, you gotta do to the other. Ha 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 ha. Okay, so what do we have? We have that 112 minus 49 is, I think is 63. Yes. 49 minus 49, leaving you with x. See that? It gets a little more complicated, right? Yeah, I know. Okie dokie. So now, what else? Fine, let us do the same problem, but using the real academic vocabulary, okay? So still, number 11, we have 16 equaling 7 plus x over 7. So I have to rewrite this as 16, and I'm gonna use a different ink. I have to write this as 16, okay, equaling to 7 plus, watch this, this is a 1 over here, 1 over 7, see I separate the number part, 1 over 7 times x. Okay, cool. Now for the proof, for the explanation. Well, the fact is the following. Whenever you have an equation that has two operations like this one, division and addition right here, there's only two properties that you will always use. Okay, so you see now we're gonna get into the properties, into the rules. There are golden rules. Yeah. Okay, first you will use, okay, and this is gonna be funny because I could have done the following. Okay, so now let's see what's going on. Okay, now let's see what's going on. First, you use the additive inverse of a number. Whenever you have a two-step equation. Yes, we did this using our common sense, using all that. It's funny how I undid division and all that. This is when you want to break your head and think about how to do it. This is more like mechanical. It's always going to happen like that. Okay? So add additive inverse. You're going to use the additive inverse. Well, the additive inverse is only used on numbers that are adding or subtracting. Right? So I'm going to use the additive inverse of 7. Because definitely this 7 is just dividing. This is the 7 that is adding. So what is the additive inverse of 7? Wait, no, not here. Here. I'm going to use the additive inverse of 7. Remember, what you do to one side, you do to the other. Don't ever put or subtract a number and then the same number on the same side. No, we are doing sides and then the other side. I have people going like -7 here, -7 here, and then all of a sudden the whole thing is wrong. No. So this cancels out. So what do I bring down? 1 over 7x, correct? What is 16 minus 7? Thank you, 9. Okay. And now, this number is multiplying the x. This fraction is multiplying the x. I know what I said, times 1 divided by 7, yes, but the fraction is multiplying the x. Alright, so after you use your additive inverse, the second property that you're going to be used is called the multiplicative inverse. Multiplicative inverse. Of what? Of the number that is multiplying the variable. So I'm going to use the multiplicative inverse of 1 over 7. And what is the multiplicative inverse of 1 over 7? 7 over 1, ugly 7. 7 over 1, ugly 7. Now, remember, as I said before, when you have a number and it's reciprocal, or a number and the multiplicative inverse, they will cancel each other. You're multiplying by 7 and divided by 7, you get 1. Multiplying by 1 and divided by 1, you get 1. So 1 what? 1x. Now here we get 9 times 7 is 63. I am not gonna bother to put over 1 because that's like corny, right? Like you don't want to put it over 1. We already understand it's a rational number and blah blah blah. Okay? Cool then. We are approaching the fantastic golden rules. So let's see now what do we have. Here we go. This was 11. 11. Wow. So right now and so far all we're doing is solving equations that have solutions. Don't worry, I'll guide you through the whole thing. Alright, let me have another equation that we have here. Okay, 12x plus 120 equals negative 48. So this is equation number 12, and we have 12x plus 120 equals negative 48. I hope you can see it. Let me see. Can I zoom in? Nah, I cannot zoom in. Actually, I can, but then my face is gonna be too big. Nah, I'm good. I'm Gucci like that. All right. So let's see what's going on here. How many operations are involved? Well, I see a multiplication, okay, by x, and I also see an addition. You see, to the left of the number, an addition of 120. So all I have to do is undo that. But remember, we're using academic vocabulary, and basically the first step that I'm going to use when we have two operations like multiplication and addition, then we're going to backtrack, we're going to reverse engineer, and I told you what are the properties used. First, we're going to use the additive inverse. We're going to get rid of, according to PEMDAS, multiplication goes first and addition goes last. Well, according to, what was that, NAPTAN, whatever PEMDAS backwards is, we're going to undo the addition first, because it's backwards. So we're going to use the additive inverse of what? Of 120. So, how do I undo this 120? With negative 120. And what you do to one side, you do to the other. See that? Okay, neater, right? Okay. And now, bring down the 12x. This cancels out. Negative 48 and negative 120 is what? Negative 168. And now, the second step is to undo the multiplication. How do I undo it? I know, don't say divide by 12 on both sides. I understand. We could divide by 12 on both sides. It cancels out and give us the number. But again, I need you to understand the multiplicative inverse step. Oh my God. Okay. So, let's see. I'm going to use the multiplicative inverse. Of what? Of 12. What is the multiplicative inverse of 12? Well, this is 12 over 1. So then the multiplicative inverse is going to be 1 over 12. So far so good? Let me see if I can make this a little bigger, but I don't want to because then I'm going to die. Let's see now. Okay. Yeah, that's much bigger as I'm going to make it. Alright. So remember, what you do to one side, you gotta do to the other. So you also multiply by 1 over 12 here. Alright, so what happens here? What is the idea behind the multiplicative inverse? The idea behind the multiplicative inverse is to get rid of what's bothering the x. Look, when you multiply a number by its reciprocal, they cancel out and leaving you with 1. Remember, look, 12 times 1 is 12. 12 times 1 is 12. 12 over 12 is 1. 1 what? Not bananas, but x. And now what is negative 168 divided by 1 over 12? Well, negative 168 times 1 is negative 168, because anything times 1 is itself. And then when you divide it by 12, which one is this one? Okay, I'm done because I don't remember. I think it's okay, so there's the 4 times. Okay, so this is well, negative times positive is negative, right? And we have negative 14. If you did it before I did, then thank you for giving me the answer. If not, lost points. Alright, so that's it. Two-step equations. Additive inverse and multiplicative inverse. Okay? Later on, you won't have to, if you don't need to, use the multiplicative inverse. You can just like, okay? So, let us do another one. Okay, so we're gonna go with 13. 13, we have 2 equals x over 4 minus 1. 2 steps. Look, we have division, which in reality is not really division, it's multiplication. And I'm gonna show you why. This can be rewritten as 2 equals, what is 1x over 4? 1 over 4 times x. Hopefully you remember. And then minus 1. Okay? Now that I have rewritten this, let me do the proof. Remember, look, I don't have to look at that. I already saw it. I saw the multiplication and the subtraction. So the first step is to use the additive inverse, and the second step is going to be to use the multiplicative inverse. As simple as that. Make sure you use it on the right, correct number. Don't be trying to use the additive inverse on a multiplication. No. No. So additive inverse of negative 1. Well, what is the additive inverse of negative 1? Nice. So plus 1, plus 1. Opposites cancel out, leaving you with 1 over 4x. 2 plus 1, 3. Okay. And now we're going to use the multiplicative inverse. What is the multiplicative inverse of 1/4? 4 over 1. I don't write over 1 because, so 4 over 1, but I'm still saying it. So that's it. When you multiply and divide by the same number, what happens? They cancel out, leaving you with 1x. Okay? Good? Alright then. Whew. Let's see now. Oh, I hate this. I really do, but we gotta do it. Okay, okay. So we have, the only problem here is that we have big numbers, but I'm gonna try to keep it as simple as possible. I lost track of the number. Should I keep I don't, what number was this? Uh, 13, okay. So, we did one-step equations, two-step equations. Now we're gonna do multi-step equations, and here I might have to start giving you the golden rules to solve linear equations. Okay, so we have, what was the number again? 13. Okay, so this is 14. 14. Can you see the 14? Yeah, you can see the 14. Okay, so we have negative 18 plus 12x equals 14x plus 44. So here now we have an issue. It's a big equation. And I am going to zoom in just a little bit because we need to, otherwise, okay, there you go. Okay, wasting time. I know we're wasting time. Would you instead, or would you better? Oh, okay, here we go. Alright, so hopefully it's more visible. And now, my head is the only thing you see there. Now, let's see what we have. When we have two-step equations, we only use the additive inverse and the multiplicative inverse. Those are the last two rules that we use when solving linear equations. But here we have more, so I'm gonna have to actually, let's see what's going on. Alright, look, what operations do we have? We have multiplication. Just because you see this plus here doesn't mean that it's adding. No, this just says that this 12 is positive. 12 is actually multiplying the x. And then there is a subtraction of 18. On this other side, we have a multiplication of 14, okay, by the x, and we have an addition of 44. But then, so what's the problem here? No, there is no issue. But before we can use the additive inverse and the multiplicative inverse, we have to make sure that we only have variables on one side. And here we have variables on both sides. So that's the first thing that we're going to address. Okay? Now, not really. Sorry. Before checking if we have variables on both sides, we have to check if we have like terms. Like terms on each side of the equation. Okay? Don't be saying, oh, 12 and 14 are like terms, so we need to combine. No, you can't combine them. This is one continent and this is another continent. They're separated by the equal sign. So then you cannot do it. So we cannot combine like terms? No. So that's why we are going to look at variables on both sides. So what to do if I have like variables on both sides? Get rid of them by using the additive inverse. Wait, but isn't the additive inverse what I need to? Yes. But whenever you have variables on both sides, use the additive inverse, okay? And usually use the additive inverse on the smaller one. So I should use the additive inverse here, okay? Now, the rule is gonna be VBS. What in the world does that mean? Variables on both sides. Do I have? Yes. So what do? Get rid of them by adding or subtracting it, right? So let me get rid of this. Let me get rid of this 12, okay, by subtracting 12x on both sides. Okay? Watch what's gonna happen. So, woo! Alright, bring down the 18 because I really didn't do anything to it. This 12x got wrecked.